Welcome back to Balvigan Bharti with your mentor Avila Sarkar. Before starting this session today, I have a declaration that I may not able to continue for some time because recently I am just moving out of this state with my family and households. Maybe I can join after an week because by that time I will settle my family there wherever in the other state, and I will come back for some time. Then after I'll move to that state again, and so in between 2 3 months I'll be very much disturbed. Still I got stability, and the classes may be interrupted in between. So I request viewers not to be disheartened that I have already uh, uh, told you in other videos together, but now it is a period where I may not able to continue for some time, maybe a week or so. So videos may not come because I am not prepared those to upload in YouTube. So this could be my last, and this is basically I'm just making and delivering immediately. So nevertheless, you just by that time see my old videos, uh, kindly revise those that have already been taught, and I request don't be disheartened, don't be demoralized, and I need your support. Wherever I'll come with a full strength that time. So as I will move on to the next problem. I have already covered 8. Now I'll move to problem number 9 in probability. So the problem on number 9, it says one card is drawn, one card is drawn from a well shuffled well shuffled pack of 52 cards. Find the probability of drawing. The first case is you have to get a face card. I'll come to this point. Let me write it down first. 10 of red suit. Third one is an ace. And fourth one is 5 of diamond. Okay. So not the end. This is third, fourth, and the fifth one is a black queen. A black queen. Okay. Now, if you know about the playing cards, you are familiar with the playing cards. Although I have discussed during my theory classes in probability, that again I will explain it to you that there is always 52 cards. There are 4 variants. Okay, so 4 variants are there. So first one is club, second one is heart, third one is diamond, and fourth one is spade. So these are the 4 variety, and each variety there are 13 cards, and their denominations are all similar, starting from 2 to 10. This is the first, then S, then joker, then queen and king. These are the variety for each case. Only thing is that clubs have a symbol of something like that. Okay, heart having a symbol of heart. This is in red color. You need to know the color also. This is in black. Diamond is of rhombus shape. This is all of red, and spade is of just a beetle leaf kind of thing, and this is also of black color. So two of is red, two are black. Denominations are 2 to 10 consecutive continuously, 2 3 4 5 6 7 8 9 10, then S, then joker, queen and king. Okay, so these are having 9 10 11 12 13. So each are having same variety. Now as you have understood the variety and the denominations of a card, now we'll start the problem. So what you will get, face. So you will need to know that a face means a face of a human being will arise in some cards where joker having face, queen having face and king having face. Apart from that, which are a pictorial means S, J, Q, K, these are pictorial. Out of that, the face will come in this card only. Joker, queen and king, they are having face. So a face card, so each having 3, so 4 variety. So number of face are 12 out of 52. So your probability will be of getting face is 12, and your space, your sample space is 52 out of 20. This is your favorable count. So this is your, so this you can reduce it to how much, 26, then further to 3 by 13. So this is the probability. Now coming to the next, number 2. Number 2, the thing is, so you done it, 10 of red. So 10 of red, I said red is coming in case of heart and diamond. So 10 will come twice, one for diamond, one for diamond, one for heart. So there are 2 possibilities of getting 10 of red, possibility of getting 2. So your probability will be getting red is 2 out of 52. So this 1 by 27. No, 1 by 26, sorry. This will be a probability. Okay. Coming to next, third. Third, what is that? So you done 2, third and ace. So ace is how many? 1 in each. So 4. So probability of getting ace is 4 out of 52. So 1 by 13. Okay. Okay, fine. So third also done. Fourth, 5 of diamond. So 5 of diamond is a unique card. So probability of getting 5 of diamond is 1 upon 52. There is no variant. So 5 is unique for any denomination, and in diamond it will be 1 only. So 1 upon. So this is your fourth done. Fifth is what? A black queen. Queen is there for every kind of card, but the queen for one kind of card is only 1. So this is also getting queen, black queen. So black where we are getting, black where we are getting for spade and clubs. So definitely we will get 2 queen, 1 for club, 1 for spade out of 52. So this is 1 by 26 again. Understood? So you need to know, you must familiar with the card. So every card you have to see separately, and you have to remember the variety of the cards. Then only you can, and you have to know what is what. Then only you can answer the question. Understood? So we'll move to the problem number 10. Okay, so there are 17 cards, 17 cards numbered 1, 2, 3, dot dot dot, all 17 means continuously are put in a box and mixed thoroughly, and mixed thoroughly. Okay, one person draws a card, one person draws a card from the box, find the probability, that the number on the card is 1, odd, 2, a prime, 3, divisible by 3, 4, divisible by 3 and 2, divisible by 3 and 2 both. Okay, so these are the case that you have to consider and to find the probability in each case. So how do you proceed? First, you need to write all the numbers so that you can distinguish the different characteristics. Okay, it is not possible to write by jumping the numbers. Rather, if you write all the numbers, you can easily find in one instance all the characteristic that is coming under the series. Now this is your sample space 1 to 17. That is clear. Now first is to get odd. So for this you need not to think, but odd is when it is divisible, it is not divisible by 2. So if we start from 1, it is odd. Alternate terms can be counted in odds. All alternate terms starting from 1 will be odd. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So your probability for first case getting odd is, how much count we have done? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of how much? 1 to 17, 17 numbers. So this will be your probability. Coming to second, what is your need? Prime number. Leaving 1, your prime number is 1, 2, 3, 4, 5, 6, 7. So these are only. So 7 means probability of getting prime number is 7 out of 17. Okay. Now third requirement is what? So 2 we did. Divisible by 3 only. So divisible by 3 you can count 3 itself, and 3 is multiple. 3, 6, 1, 2, 3, 4, 5, only 5. So divisible by 3 is 5 out of 17. Okay, so this is the case. Third one is completed. Fourth, it is saying divisible by 3 and 2. So the number which is divisible by 3 and 2 must be the multiple of the LCM of 3 and 2. So 3 and 2, if I do LCM, how much will get? 6. So the number should be 6 or 6 multiple. So how many numbers? 1, 2 and nothing. So probability of getting 3 and 6, 3 and 2 divisibility. So this is equal to 2 only out of 17. Understood? So this is your probability. So moving next, it will be 11. How length it is? Okay, fine. A box contains 90 dishes, 90 dishes means plural of dices, which DISCS discs, okay, which are, it is not dice actually, it is discs, which are numbered from 1 to 90, okay, 1 for each, okay, the number is given 1 for each. If one disc is drawn at random from the box, find the probability that it bears the first bit is a two-digit number, okay. Second, a perfect square, okay. Third, a number divisible by 5, a number divisible by 5. So I have written short, you can understand. The requirement is the number divisible by 5. So I have just written the exact requirement, okay. So 1 to 19 there may be a variety of numbers, so that's why this kind of different requirement may arise, or there may be some more requirement, but out of this these all are possible. A two-digit number, while we are counting from 1 to 19, your two-digit number starts from 10 till 90. So number of two-digit number, if I say 1 to 90 is 90, discarding 1 to 9, so that means from 10 onwards to 90, how many numbers will be there? It will be how many numbers? It will be 81 numbers, isn't it? Including 10, because 11 to 90 is your 80 plus 10, it will be 81. Don't make mistake. People may mistake because 1 to 10 they deduct, but 10 to 90 means including 10. This is also 10-digit number. So for first case, your probability getting two-digit number is how much? 81 out of 90 possibility, isn't it? If I draw one disc, we are drawing one disc, okay, so there is a possibility of getting this much, so that is 9, 9, 9, 10. So this way. 2, but it says a perfect square. So in between, what is the perfect square? If I see the perfect square where from 1 to 9, if I take from 1 to 9, the square is 4 and 9. Okay. Then after 10 to 20, your perfect square is 16 only. Then 20 to 30, your perfect square is 25. So that means 2 square, if I see the pattern, 2 square, 3 square, 4 square, 5 square, like that. So till how many square? 90. That means 9 square will be the 81. Then after the 10 square means crossing 100. So 1, 2, 3, 4, 5, 6, 7 and 8. 1, 2, 3, 4, 5, 6, 7, 8. This much of square will accommodate between 1 to 90. 2 square, 3 square, 4 square, 5 square, this much. So getting perfect square is how many? 1, 8. This is only possibilities upon 90. So if you reduce it, you will get 4 upon 45. This much will be the possibility, because we are counting the perfect square, not the value. Remember, this is the perfect square, and this also, sorry, I made a mistake. 1 square is also a perfect square, so 1 has to be considered. So from 1 square, 1 is a perfect square, 1, 2, it count will be 9. Sorry, I made a mistake. It must be 9. So your answer will be 1 upon 10. See, one single mistake will lead you to a different result. So keep your mind open, because 1 I have not considered because it is starting from 1. So 1 is a perfect square. So 1, 2, 3, 4, 5, 6 up to 10. So this is 9 numbers. So this is the case. Now the last one is getting what? 1, 2, 3. You did 1, 2. The divisible by 5. So out of this, divisible by 5 means 5 is the least which is divisible by 5. So any number which is multiple by 5 up to 90 will be the divisible. So what are the numbers? 5, 10, 15, 20, 25, 20, 30, then 35, 40. So in this case, how much, if we go with 5 ones are 5, so multiple of 1, 2, 3, and 90 multiple is how much? 5 multiple means 5 into 18. So 1 to 18 will be the count. So I need not to go with this. Rather, if 5 is multiple of 1, it is divisible by 5. So 1 to 18, if I multiply with 5, I will get all the numbers which is inside this 1 to 90. So how much count? 18. So probability of getting multiple of 5 is 18 out of 90. So that is equal to 1 by 5. Okay. So this is your result when it is divisible by 5. So end up here, and hoping that you will not leave me alone. I will come back definitely, but it will take a bit time, because I am not in a position to prepare such videos anywhere, because by the time I may be traveling and I am not settled down somewhere to make my mind to make such comfortable videos. So pardon me for that, but definitely will come when I again regain my position. And in between after 2 months also there will be disturbance, because that time also I may be traveling. So somewhat there will be disturbance. So pardon me for that. I ask your excuse for that. So be with me and hope that I will bring good for you. So thank you. Good night.